all. It's an very beautiful invention in the middle of 20th century, and it goes boon for us. And slowly, it is inevitable part, and it got replacement of each and everything. But every coin has two sides, whether it is king or cross. And then slowly it was invented that it is the cause of global warming and unwanted waste, which is not uncomposed, which is not degradable. So our team thought an innovation about the novel synthesis of biodegradable polymer from curcubita peel. Curcubita is a scientific name of pumpkin. It is a scientific name of pumpkin. So now a question is arise whether planet or plastic. And second thing is that, okay, if we attach to the plastic, how to detach? Attachment is very critical process, but detachment is very slow process. If we are attaching to anyone, then detachment is slow process. So it is not a miracle to or 1 day 2 day process to replace the plastic, but we can try our best and we will definitely get the success over it. So pumpkin, why we choose the pumpkin? Pumpkin is rich in pectin. Second thing, pumpkin and by the survey we got that it is also utilized to extract the alcohol insoluble polysaccharides natural polymer. So second thing is that environmental pollutants are also reduced by biodegradable plastic, and biodegradable polymer can be used in food packaging also. So it can be used in food packaging. And second thing is that there are so many biodegradable ways, just like oxidative biodegradation, which is done by normal air. Second thing, the oxidative degradation, photodegradation, which can be done by the directly by the help of sun. And therefore we have decided to synthesize in our lab biodegradable plastic. So these are the normal common features, and this is a comparison of bioplastic versus the conventional plastic. So second thing is that bioplastic is more sustainable, whether the conventional plastic is unsustainable. Physically biodegradable, so it is naturally non-toxic, while conventional plastic is toxic because its degradation is very impossible. It causes gases, and it will make our earth in endangered position. Secondly, less use of energy will be there in to prepare bioplastic. We will go further in that synthesis part also, so we can see that. And second thing, more energy usage will be in the production of the conventional plastic. Eco-friendly is the main feature of the bioplastic, and no harm to abiotic feature, while conventional plastic is making the very harmful situation for marine life as well as animal and mankind also. Second thing, it increases soil fertility also. This we proved also because our synthesized plastic was very rich in NPK content. NPK means it is a main component of a manure, nitrogen, phosphorus and potassium. So we are getting also the result, very exciting result about NPK content. Nitrogen we got 7.2%, phosphorus 3.2, and potassium we got 2.8%, which is in a good range. And recycling and destroying process is difficult of bioplastic, but conventional plastic recycling and destroying process is relatively easy, but it need energy. So second thingly, we got whether it is recycling and destroying process is although difficult, but we got very good option about it because our bioplastic is rich in NPK content, so it can be used in manure, it can be used as a compost, it can be used as a fertilizer. So we are disclosing our technology, that is a synthesis of biodegradable plastic film B and C. That is only the difference between the plastic B and C is the only filtration process. So the biodegradable plastic film B we are using by this material, that is a dried pumpkin, cornstarch, glycerol, citric acid, gelatin and water. So normal method is what? We have to mix the all content, and we have to raise the mixture about 95 to 100 degree, and we will evaporate the water part up to the slurry point, and it will be up to maximum 15 to 20% of the total volume, and just we pour to the petri dish, and we will dry it in the sunlight only, and after drying we are getting the moisture, and when we are getting the constant moisture, we are getting the biodegradable plastic. And this is the costing. Both costing is same because only the filtration process is different. Now these are the photographs of there is a reaction mixture poured on petri dish, and there is a dried biodegradable plastic. And second thing, a reaction mixture poured on a petri dish after filtration, and we are getting the dried bioplastic film. Now only we have synthesized the biodegradable plastic of biofilm B and C without getting insertion of newspaper. But the next biodegradable plastic film D is the use of curcuita powder and the newspaper also. So in that we have inserted newspaper, and method is the same as the above, and we are concentrating the mass up to the 20% just like the slurry point manually, and then we are pouring it into petri dish, and we are getting the biodegradable plastic. This is just how we make the paper sludge after heating this, and then we are getting the paper sludge, and we are inserting into the reaction mixture. And we had done the cost cutting experiment also, because bioplastic B, C and D, they were up to somehow costly, so we wanted to reduce the cost. So for that, what we have done, we have increased the amount of waste newspaper, which was very cheap, and second thing, dried pumpkin peel we have powder we have increased. So in that case also we are getting success, and we got the weight also, you can see that 15.86 gram, which was very high, and it was around 90 to 95% yield, and which was the more before the previous experiment, which were around 75 to 80%. And costing, we can see that is a 4.74 Indian rupees, that it is very lesser than the previous one. It can be definitely compared by the 1 kilogram rate. So this is the table for what we have synthesized the biodegradable film, and it is just like the weight, whatever we got the weight, and according to that their rates are there. So markedly we are getting the comparison of converting that rate to the 1 kg, and we are getting drastically less rate of the cost cutting experiment biodegradable plastic, which is 298 rupees per kg. So nowadays, if you will buy polypropylene for the conventional plastic, it is generally 100 to 120 rupees per kg, but the energy required and the process required for that, it will cost more. So next is, we can see the resultant discussion. Our plastic water absorption test, it can be it is water absorbing, so we are developing now the technology to cover that biodegradable plastic by polyvinyl alcohol to get the water resistance also. So these our films are getting the water absorbed, and so they can be composed in the aqueous media also. We had done biodegradability test in soil also. So what we had done, we had weigh a piece of the biodegradable plastic, and we have composed in the soil, and after 7 days, 10 days, and periodically we have monitored the weight. So we are getting the decay of the weight, as well as after 35 to 40 days the whole piece of the biodegradable plastic was composed, and it diminished in the soil. And after that we had done the soil fertility test also, so it was more richer in nitrogen, phosphorus and potassium as well. So because already our film was richer in the nitrogen, phosphorus and potassium that I described already, in that nitrogen was above 7%, potassium was 3.4, phosphorus was 3.4%, potassium was 2.8%. So these are the IR analysis, and IR analysis support our insertion of pumpkin peel powder into our biodegradable film. So we can see all this is a pumpkin peel powder sire. So OH peak, that is moisture which is coming in 3100 to 3700 centimeter inverse broad peak. Then there is a CH that is already presence in the glucosides. And second thing, CO, there is a ethereal linkage, CO, that is around 1100 to 1200, and this is OH of deflection water, or it is COH bond also, and second thing CO, that is a carbonyl carbon bond. So this is a pumpkin peel powder, and this is a pumpkin peel powder bioplastic film. This is a IR insertion, that is a overlapping data also. So we can see the maximum peaks are overlapping to each other. In that also bioplastic from pumpkin peel C, we are getting maximum peak of the cucurbita peel powder, and this is a bioplastic from pumpkin peel and newspaper mixture also. So in that also we are getting the maximum cucurbita peel powder IR peak. That is a comparison same as the above we had done. So maximum peaks are coming, and this is a comparison of IR data between the cucurbita peel powder and the newspaper mixture. So we feel challenge is that how we can get the maximum number of pumpkin peel powder. So we can collaborate with the industry of sweet, just like in Agra पेठा मिलता है जो, तो it is a sweet, so it needs this. So we are means we wanted help from the industry to grow this technology. And conclusion is that biodegradable plastic films from pumpkin peel and newspaper were successfully formed. Their biodegradability in aqua as well as soil and proved biodegradable. And from IR analysis, we confirmed that all the maximum 95 to 98% peaks are we found in the biodegradable peak. So naturally it is insertion was there. And as fruit and vegetables peels are going wasted, agro waste are there, and we can get the best out of waste method from this. Thank you. So, I want to acknowledge my teammates Dipen Panchani and Harsh Patel, and I would like to thank IPTA for giving me this opportunity. I would like to thank CFTRI, and I would like to thank MK Goel sir and Shaili ma'am for whenever I need the help. So definitely there was a help, and thank you Mahesh Gandhi sir for addressing the session. Thank you.